Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. I will now show that how you can take the reading in a consolidometer, and you have to take the reading after elapsed time. Let us say that here I am showing that 0.25 like that, 1.09, 2.48, and you continue take the reading like that up to 40 minutes. And this is the root of t time in minutes. So, this is for root, this value is also given, that is 0, this is 0.5, this is 1, 1.5, like that you continue up to 1440, that is it will be about 17.9, and this is the root of t value. So, you have to apply the load, and initial load in a consolidometer is 0.1 to 0.2 kg per centimeter square. You apply the load 0.1 to 0.2 kg per centimeter square, and you keep on take the reading in a dial gauge reading. So, this is the dial gauge reading starting from 16.634, then at a time of 0.2 of 5, then your dial gauge reading is 16.392. Like that you continue after the different elapsed time, you take the dial gauge reading for a loading of 0.1 to 0.2 kg per centimeter square. You take the reading, and this last reading is about 16.243. Okay. Then again you start from the beginning, let us say next day after the 1440 hour, and you increase the load, that is 0.2 to 0.5 kg per centimeter square, and then you are taking the reading for the defined time. Okay. Let us say 0.254, you are taking the reading about 16.180. Okay. You keep on reading like that under the different elapsed time up to 1440. Okay. And then at a load of increment of 0.2 to 0.5 kg per centimeter, and this last reading is 16.101. So, this was the 16.101 again, then again you are increase the loading, okay, that is 0.5 to 1.0. Then you take the reading again, that initial reading is 16.601, and under the different elapsed time you keep on take the reading, and after the 1440 hour at a load of 0.5 to 1.0, you are having a dial gauge reading about 15.539. Then again you apply the load increment 1 to 2, then keep on reading like that from 0 to 1440 hour. Then again you increase the load from 2.0 to 4.0 kg per centimeter square, and under the different elapsed time you take the reading like this, and then again finally 4.0 to 8.0 kg per centimeter square increment loading, then you take the reading, okay, under the different elapsed time. So, you know that how to take the reading with the incremental of the load, and after the loading again you require for unloading. So, how you can unload this. So, this is the unloading, let us say 0.0, and then at a time of 30 minutes, you can see this was the initial loading under the load of initially 8 to 4 kg per centimeter square, then you unload it at a particular time, you are having this dial gauge reading 12.443 when you are unloading. Then from 2 to 4 kg per centimeter square, and after 30 minutes 12.543, then 2 to 1, 1 to 0.5, 0.5 to 0.2, 0.2 to 1, and then 0.1 to 0, and ultimately you can have this dial gauge reading in 30 minutes. Okay. Then this is the unloading condition. The earlier one, it was the loading condition, and from this reading you can calculate this defined value. I am showing that how to calculation of the void ratio. So, I will show that calculation of void ratio. So, this calculation of void ratio, to calculate the void ratio, you should know what is specific gravity. So, let us say specific gravity of soil is G is equal to 2.75, and you know that height of the sample in a consolidometer, that is height of the sample, let us say that is equal to h is equal to 25 millimeter. Then area of the sample, that designated at A, and this is equal to 44.15 centimeters square. You can calculate that what should be the dye mass of the sample. So, let us say dye mass of the sample is equal to 145 gram. Then you can calculate what should be the height of solid, which is designated at h of s, and that is equal to V of s, this divided by A. That means this is dye weight of soil, this divided by G into A. So, where Vs, you know that G is equal to rho S by rho of W is equal to M of S divided by V of S into rho of W. So, you can write that V of S is equal to M of S, this divided by G of gamma of W. So, you know the Vs. So, Vs is equal to Ms by G gamma W into A. Okay. So, that is why we can write that dye weight of the soil, that what will be the dye weight of the soil divided by G by A. So, this you can write, you know that what is that M of S, you know that what will be the G value, you know that this is gamma W is equal to the 1. So, in place of Vs you can write Ms by G gamma W. So, that means height of the solid, that means H of S you can write Vs is Ms by G gamma W. Okay. That means you can write what will be the weight of the solid, this divided by G, and this is gamma W into this is A. This is A. So now if you substitute the value that dry weights of the solid of the soil. So this is MS is equal to 145 and G value is given 2.75, gamma W is 1 and A value is given 44.15. So we can write that H of S that means H of S is the M of S divided by G gamma W into A. So this is solid is 145. Okay. So you can write 145 this divided by and G value is given 2.75. So this is 2. Well, next we can write that H of S is equal to M of S this divided by G into gamma W or rho W into A. So you know that MS we have calculated dry mass weight 145. So you can write 145 this divided by G value is 2.75. So so, G value is 2.75 or gamma W or rho W is equal to 1 into the area 44.15. So, this is 44.15. Okay. Now, if we calculate, then we can write that height of the solid will be equal to 1.194 centimeter or is equal to 11.94 millimeter. So, we calculate the height of the solid is 11.94 millimeter. Now, you should know what will be the initial height of void, initial height of void. Okay. Initial height of void, we know that in the beginning that height of the sample was 25 millimeter. So, initial height of the void 25 millimeter minus is 11.94 millimeter. This is height of the solid. So, this if you subtract, you can have the initial height of the void, that is 13.06 millimeter. Okay. So, from this you can calculate the what should be the initial void ratio, and this is designated at E of 0. So, E0 will be what will be the height of the void, this divided by height of solid. So, what is the height of the void? Height of the void 13.06. So, we can write 13.06. This divided by height of the solid. So, here we calculate height of the solid 11.94. So, this is 11.94. So, if you calculate, then you can have the initial void ratio E0, that is will be 1.09. So, you can calculate that what will be the initial void ratio, that is 11.09. Okay. Now, I will show you some specimen calculation for consolidation test. Some specimen calculation. I am showing here that this is the table for specimen calculation. So, initially you have to apply the load 0.1 kg per centimeter square to up to 8 kg per centimeter square into the soil sample. Okay. Then you unload the sample, that is 4, then 2, 1, then 0.5, 0.2, 0.1 and 0. So, this part is the loading. Okay. This is the load applied in kg per centimeter square from 1 to 8 kg per centimeter square. Then you unload the sample, that is from 4 kg per centimeter square to 0.1 kg per centimeter square. Then you take the final dial gauge reading. So, your starting reading is initially it is 16.68, this is 16.865, then 16.434, like that you are taking this dial gauge reading, and dial gauge reading you can say it is decreasing. Then at the load of 8 it is 12.410. So, then you have to determine that what will be the compression in millimeter. Okay. I will show you one of the under the loading of 0.1 kg per centimeter square, and this is the dial reading 16.434. Then what should be the compression, okay, under the loading of 0.1 kg per centimeter square. This I will only show you, and then accordingly you can also calculate for the other loading and also reloading, unloading. So, this is 16.43. So, compression your D in millimeter is 16.865 minus 16.434. Okay. So, you can have the compression value 0.431. I am showing here that you are calculating that compression. Okay. So, let us say that at a particular loading, when loading is 0.1 kg per centimeter square, this is kg per centimeter square, and then you are taking what will be the final dial reading. And let us say that at the 0 loading, so you are having the dial gauge is 16.865, and for this one loading you are having 16.434. So, then you calculate what is the compression, okay, compression in millimeter. So, compression will be 16.865 minus 16.434. So, this will give you 0.431 millimeter. So, you can calculate that what will be the compression, okay, that is compression is D. Now, you can calculate the what should be the height of void. Okay. Height of void, that means h of v is equal to h of v0 minus d. This is d. So, what is the h of v0? So, h of v0, initially we take the reading, and for 0 it is your 1.09. Okay. And for a load of 1 kg per centimeter square, then height of void will be equal to, let us say that this is height of void is equal to h of v0 minus of d. That means initial void will be the 13.06, and then under the load of 1 kg per centimeter square, this is 12.629. Okay. So, this is the h of v is equal to h of v0 minus d. So, what is h of v0? H of v0 is 13.06. That means, if I write 13.06 h of v0, and this minus that 0.692, this 0.692. .69, this is 2. So, this will give you the value of 12.438. So, this value H0 V0 minus D will be equal to your 12.438. Wait. Repeat. So, here I am showing one that calculation for the load increment for 0.1 kg per centimeter square. For 0.0, this is the final dial gauge reading, that is 16.865, and for 1 loading is 16.434. Okay. So, here I am showing for 1 kg loading, that is loading is kg per centimeter square, you are having the dial gauge reading 16.434. So, compression, that is D in millimeter, will be 16.865 minus 16.434. So, if you deduct, you can have 0.431. So, this is 0.431, that is D, compression. Now, height of the soil under 0 load, it was 13.06. So, height of the void is equal to HV0 minus D. So, initially we have calculated that what is HV0. So, initial height HV0 will be equal to here that initial height of the void 13.06. So, initial height is 13.06. So, HB0 13.06 as I showed you minus D. So, HB0 13.06 minus 431, 13.06 minus 431, that means 12.629. So, we can write 12.629. Now, you calculate what will be the void ratio, that is the E. Okay. So, void ratio is equal to E is equal to height of void divided by height of solid. Okay. So, initially this value, initial void ratio value we have calculated earlier, that is E0 is equal to 1.09. So, it is 1.09. Okay. So, 1.09. Then next, at 0.1 kg per centimeter square of loading. So, we have to check what will be the void ratio. That means, this is HB is equal to 12.629, here 12.629, this divided by height of the solid. So, height of the solid we calculated 11.94. So, this is height of the solid 11.94. So, 12.629 is the HB for a load of 0.1 kg per centimeter square, and height of the solid, as I showed you, height of the solid is about 11.94. Okay, 11.94. So, 12.629 divided by 11.94, it gives 1.05. So, here E value will be equal to 1.05. So, it will be 1.05. Then you calculated delta of E, okay, change in void ratio. So, change in void ratio 1.05 minus 1.049, that means it will give minus 0.040. So, we can write here minus 0.040, that is change in the void ratio. So, you can calculate that what will be the change in the void ratio. So, similarly, you can calculate what will be the delta sigma dash AB and the MB. So, AB can be expressed as centimeter square per kg, and MB also can be expressed as centimeter square per kg. Now, how to calculate the AB value, okay, and how to calculate the MB value? I am showing it. Let us say change in void ratio, that is delta of E is equal to E2 minus E1, that is 1.05 minus 1.09. So, this will be minus 0.04, what I showed you in this table, that is 0.04 void ratio, change in void ratio. Now, incremental load, that is delta of sigma is equal to sigma 2 minus sigma 1. What is sigma 2? It's 0.1 kg per centimeter square, and initial loading is equal to 0. So, delta sigma will be equal to 0.1. So, this delta sigma will be equal to 0.1, because initial loading is 0.1 and this is 0. So, 0.1 minus 0 will give the delta of sigma, that is 0.1. So, this delta of sigma is equal to 0.1, that is kg per centimeter square. So, this delta sigma is kg per centimeter square. Now, we have to calculate that AB, that means coefficient of compressibility. So, this coefficient of compressibility can be expressed as AB is equal to minus delta E by delta of sigma. That means minus 0.04. This is delta E is equal to minus 0.04. This divided by delta of sigma, that means this delta sigma is equal to 0.1. So, if you calculate, you can have the AB value is equal to 0.4 centimeter square per kg. So, you can calculate AB 0.4 kg per centimeter square. So, you can write this is AB value is equal to 0.4 kg per, this is centimeter square per kg. So, AB is 0.4 kg per centimeter square. Now, we have to calculate that what is MV, that means coefficient of volume change. So, MV coefficient of volume change, that is M of V. So, we know that equation MV is equal to minus delta of E, this divided by 1 plus E of 0 into del of sigma. So, this is minus delta is mean minus 0.04, this divided by 1 plus E0 means 1 plus 1.09 we have calculated earlier, this into delta sigma is at a load of 0.1 delta sigma. So, if you calculate this, you can have 0.191, that is centimeter square per kg. So, this is coefficient of volume change MV is equal to 0.19 per centimeter square. So, we can write here MV value is 0.191 centimeter square per kg. So, you know that E0, this value is known, that is the 1.09, it is E0, and delta sigma means increment, we have calculated here 0.1 kg, so 0.1 kg. So, and delta you know 0.04, so you can have this value of MV. So, you can calculate in this table all the value, what is the AB, what is the MV value. So, this value is important.